So good morning. So we'll have about 10 temperature sensors. So there is a wide variety of temperature sensors that are available to simplify the broadcast possible range of temperature monitoring challenges. These silicon temperature sensors differ significantly from the above mentioned types in a couple of important ways. The first is the operating temperature range. A temperature sensor IC can operate over the nominal IC temperature range minus 55 degrees Celsius to 150 degrees Celsius. The second major difference is functionality. The silicon temperature sensor is an integrated circuit, which can therefore include extensive signal processing circuitry within the same package as the sensor. There is no need to add compensation circuits for temperature rises. Some of these are analog circuits with either voltage or current output. Others combine analog sensing circuits with voltage comparators to provide alert functions. Some other sensor ICs combine analog sensing circuitry with a digital input or output and control registers, making them an ideal solution for microprocessor-based systems. Whereas the digital output sensors usually contains the temperature sensors, ADC, that is analog digital converter, a two-way digital interface, and registers for controlling the IC's operations. Temperature is continuously measured and it can be read at any time. If desired, the host process can instruct the sensor to monitor temperature and take an output pin high. If the temperature exceeds the program limit, lower threshold temperature can also be programmed and the host can be notified when the temperature has dropped below this threshold. Thus, the digital output sensors, which can be used for reliable temperature monitoring in microprocessor-based systems. Whereas the case of an temperature sensor, which has a three terminals, required maximum of 5.5 volt supply. This type of sensor, which consists of a material that operates according to the temperature to vary the resistance. This change of resistance is sensed by the circuit and it calculates the temperature. When the voltage increases, then the temperature also rises. We can see these operations by using a diode. The temperature sensors directly connected to microprocessor input and thus capable of direct and reliable communications with microprocessor. The sensor unit can communicate effectively with low-cost process without the need for A to D converters. So an example of temperature sensor is to be an LM35. So these 35 series are precision integrated circuit temperature sensors whose output voltage is linearly proportional to the Celsius temperature. So the LM35 operates at minus 55 degree to 120 degree Celsius. The basic centigrade temperature sensor is shown below over under. Okay, so what about the features? So it can calibrate it directly in Celsius. It rated for full for minus 55 to plus 1 degrees range. It is suitable for remote applications. So we'll have a low cost due to water level trimming. It operates from 4 to 30 volts and will have a low self-heating. So plus or minus 1 by 4 degrees Celsius of typical non-linearity. So this is the schematic diagram. And when you are saying about an operation, so this can be connected easily in the same way as other integrated circuit temperature sensors. It can be struck or established to a surface and its temperature will be within around the range of 0.01 degrees Celsius of surface temperature. This presumes that the ambient air temperature is just about the same as the surface temperature. If the air temperature were much higher or lower than the surface temperature, the actual temperature will die would be at an intermediate temperature between the surface temperature and the air temperature. The temperature sensors have well-known applications in the environmental and process control and also in the test measurement and communications. A digital temperature sensor which provides 9-bit temperature readings. The digital temperature sensors offer excellent precise accuracy. These are designed to read from 0 degrees Celsius to 70 degrees Celsius, and it is possible to achieve plus or minus 0.5 degrees Celsius accuracy. These sensors completely aligned with digital temperature readings in degrees Celsius. Digital temperature sensors eliminate necessity for extra components such as an A to D converter within the application, and there is no need to calibrate components or the system at specific reference temperatures as needed when utilizing thermistors. Digital temperature sensors deal with everything, empowering the basic system temperature monitoring function to be simplified. Whereas in the case of an advantages of digital temperature sensors, which are principal with its precision output in degrees Celsius, the sensor's output is a balanced digital reading. This intends no other components as an analog to digital converter and much simpler to use than a simple thermistor that provides a non-linear resistance with temperature variations. An example of a digital temperature sensor is DS162N, which provides a 9-bit temperature reading. So when you are saying about time features of DS162N, so there is no any external components required. The temperature range will be from minus 55 to 125 degrees Celsius. It gives temperature value as a 9-bit reading. It has a wide power supply range. It converts temperature to digital word in less than 1 second. Thermostatic readings are used. It is indefinable and non-volatile. It is a 8-pin. It is a 8-pin DIP. So this is the pin configuration of an 8-pin DIP. Pin description. So we'll have a SDA2, SCL, ground, thermostat output signal, A0 chip address input, A1 chip address output, chip address input, and A2 will have a chip address input. So VDD will have a power supply voltage. Okay. So when we are saying about TAN, so this is the pin configurations. So when you are saying about TAN, when the temperature of the device which exceeds a user-defined high temperature, then the output T out is active. The output will remain active until the temperature drops below the user-defined temperature low. The user-defined temperature settings are saved in a non-volatile memory, so it may be programmed before insertion in a system. The temperature reading is provided in a 9-bit 2's complement reading by issuing the read temperature command in the program. A 2-wire serial interface is used for input to the DS16121 for the temperature settings and the output of temperature reading from the DS121. So we'll have two different types, contact temperature type sensor and non-contact temperature type sensors. So when you are saying about a thermostat, it is a contact type electromechanical temperature sensor. So this is to be that. So when you are saying about TAN, so it is basically consists of two different metals such as nickel, copper, tungsten, and then or aluminum, etc., which are bonded together to form a bimetallic strip. The different linear expansion rates of the two dissimilar metals produces a mechanical bending movement when the strip is subjected to heat. The bimetallic strip can be used itself as an electrical switch as a mechanical way of operating an electrical switch in the thermostatic controls and are used extensively to control hot water heating elements in boilers, furnaces, hot water storage tanks, as well as in the vehicle radiator cooling system. So this is the diagram which shows over here, which is closed, which is open due to heat. We'll have a open circuit conditions. So the thermostat consists of two thermally different metals stuck together back to back. When it is cold, the contacts are closed and the current passes through the thermostat. When it gets hot, one metal expands more than the other and the bonded bimetallic strip bends up, opening the contacts, preventing the current from flowing. So we'll have an on or off thermostat. There are two main types of bimetallic strips based mainly upon their movement when subjected to temperature changes. There are the snap action types that produce an instantaneous on or off or on type action on the electrical contacts at the set temperature point, and the slower creep action type that gradually change their position as the temperature changes. So snap action type thermostats are commonly used in a home for controlling the temperature, whereas creeper types generally consist of a bimetallic coil or spiral that slowly unwinds or coil up as the temperature is. Generally, creeper type bimetallic strips are more sensitive to temperature changes than the standard snap on or off types as the strip is very longer over on it. Okay, so by that this class is over. The remaining thing we can see in the